Hello and welcome again. In the previous video, we started talking about multiplication in this Galois field. And remember, this Galois field is a collection of all polynomials of degree 7 or less with coefficients 0s and 1s. And so we multiplied last time, but we didn't have to do the division because the degree of this product was small. So small means degree less than 7. Now let's look at an example where we actually have to do the division, compute the remainder after we multiply. So we're gonna have this. We're gonna find the multiplication of ax times bx, where ax stands for this polynomial, x to the fifth plus x cubed, and b of x is this other polynomial, x to the 7 plus x. And we're gonna multiply these two polynomials, and the idea is when I do this product, it's gonna give me again another element of this Galois field. All right, so let's look at the solution. Now, I wrote down here the byte representation of every these two polynomials here. You don't actually have to do it to do the multiplication, but I'm just going to do it to emphasize the fact that these polynomials actually represent byte. So this polynomial that I have here, x cubed, x to the fifth plus x cubed, is represented by this byte that is right here. So we have, you see here, we have a 1x to the third power, and we have 1 x to the fifth power, and we don't have any other power, so that's why we have the zeros there. And then similarly with this one, x to the 7 plus x is represented by this byte that you see here. So in theory, we actually multiplying these two bytes, but in this special way. So what we're gonna do is do the multiplication. So we start first with normal multiplication of polynomials. And remember, you multiply normally, but then when you combine, you're gonna sort the common values. Now, there is an important thing that we have to remember here is every single time you're going to multiply polynomials and the degree of the multiplication is larger than 7, then you will have to divide by this polynomial, which is a special polynomial here that is not part of the Galois group, but it's a special polynomial that we use to do the multiplication in the Galois group. And remember, this is the polynomial we're going to divide by in case this product happens to be larger than the degree of 7, which is going to be because you see x to the fifth times this one is already degree 12. All right, so let's go ahead and do the multiplication first. So we're going to multiply ax times bx in a normal way. So let me do that over here. So I'm going to take x to the fifth plus x cubed and multiply it by the other polynomial, which is x to the 7 plus x. And those are the polynomials. Of course, we are talking about these two polynomials here. As you can see, x to the fifth plus x cubed, x to the 7 plus x. All right, so let's do the multiplication. Normally, when we do multiplication of polynomials, so we're going to FOIL this. So we're going to take x to the fifth, multiply by x to the 7, and x to the fifth also multiplied by x. And so let's see the result here. Let's write down the result. So x to the fifth times x to the 7. Remember, you add the exponent, so it's going to be 5 plus 7, that's x to the 12. All right. Now, same again, x to the fifth multiplied by x is x to the sixth power. It's going to be plus x to the sixth power. Then what we have is we're done with these x to the fifth. Now we move to x cubed. So we're going to multiply by that. So let's say, I'm going to use another color here, x cubed that multiplies the x to the 7, and x cubed that multiplies the x. So in this particular case, what we have is this x cubed multiplied by x to the 7, add the exponents. 3 plus 7 is 10, so it's going to be plus x to the 10th power. And then finally, x cubed multiplied by x is x to the 4th power. And that will be the answer. I don't need to combine anything here because there is no common terms here or like terms. So I don't have to do that. So if they were, do you actually go ahead and combine them like the way we did in the last example? Now, I'm going to organize this in decreasing order of powers. Now, we don't have to do it, but it's better to do it that way. So let me write this down like this. It's going to be x to the 12th power plus x to the 10. That's going to be the next power plus x to the 6th power plus x to the 4th power. So I have exactly the same polynomial here and here. It's just that this guy is organized in decreasing order of powers. And of course, this guy here, the idea is that this has to be an element of the Galois field, but it's not because this degree is degree 12 here for this polynomial, so it's not in the Galois group. So what you need to do is this. Whenever you do this multiplication here, and you get a degree that is larger than 7, you need to divide this polynomial that is right here, divided by px. That way you will reduce the polynomial to degree 7, and that will be the answer that the multiplication in this case will be. The answer will be whatever the remainder of the division, you take whatever the answer you get, which is this one, divided by p of x. That answer will be, the remainder will be that, what we call the product in the Galois field. All right, so I'm gonna start with a blank page here. So what I'm gonna do exactly what I just said. I'm gonna take this guy and divide it by the polynomial. Now there are two ways to compute the remainder. This is the one way, which is a straightforward division. In the next video, I'm gonna show you another way that you can also do it without doing the actual division. So, but in here, I'm gonna do the normal division of polynomials. So I'm gonna take the polynomial, and as you remember this from maybe college algebra in high school or the first semester in algebra, I'm gonna take x to the 12 plus x to the 10th power plus x to the 6th power plus x to the 4th. That is my result after I multiply this one right here, x to the 10 plus x to the 12 plus x to the 10th power, x to the 6th power, x to the 4th power. I put it right here, and I'm gonna divide it by p of x, which is my special polynomial. That's the special polynomial in the advanced encryption standard. Remember, this is one of the important parts of the advanced encryption standard there, so that polynomial. So I'm gonna take that and divide it by that polynomial. So I'm gonna divide it by x to the 8th power plus x to the 4th power plus x cubed plus x plus 1. That is the polynomial px. This one right here, this is px. And so I'm dividing the product divided by px. Right. So what we're going to do here is we're going to do the division of polynomials the way you do it in college algebra. So let's see that. So remember, let me recall more or less the algorithm. So the algorithm goes like this. You're going to divide this one by this. What you do is you select the largest power here, which is x to the 12, and you're going to divide it by the largest power here, which is x to the 8th. So what I'm doing is this. I'm going to take x to the 12th power divided by x to the 8th. Let me do that computation here on the side. So what I'm going to do is I'm going to take x to the 12th power divided by x to the 8th power. Now, if you apply the rules of exponents, x to the 12th divided by x to the 8th, that's x to the 4. Because it's 12, is it this number, this exponent, 12 minus 8, here, that's x to the 4th power. So that gives me x to the 4. Now, this guy here, that quotient that we just did, we put it in here, in where you put the quotient here. So that's going to be x to the 4th. Okay, it's exactly the same as you do in college algebra when you do polynomials. Now, once you compute this, this quotient here, you multiply this quotient by this one, by this whole polynomial, and you're gonna add it in this case. You're not gonna subtract, you're gonna add it here. Okay. Now, in normal division of polynomials, you're gonna subtract, but addition and subtraction in the Galois field are exactly the same thing. Okay, so that's why we're just gonna add it here. So, and this is gonna work like that. All right, so again, this is how you do division again of numbers. Remember, you take this number, how many times this number is in this one, it's x to the 4 times, you multiply this by this and do the subtraction here, right? But in this case, we're gonna do addition, because addition in the Galois field is exactly the same as subtraction. So I'm gonna do the addition there. So I'm gonna do is, I'm gonna take x to the 4th, multiply by x to the 8th, that gave me x to the 12th. Right. Now, x to the 4th, multiply by x, this x to the 4 is x to the 8th, so I'm going to write down plus x to the 8th. Now, x to the 4th, multiply by x cubed, that's x to the 7th, so I'm going to have x to the 7th, and x to the 4th, multiply by x is x to the 5th power, so plus x to the 5th power, and then finally, I get x to the 4th, multiplied by 1 is x to the 4th power. and I'm gonna add them. Because the addition here, remember in the Galois group, is the XOR, so once I take x to the 12 and add it to x to the 12, it is 0, so they cancel out. So this is gonna cancel out here. So this cancels out with this one. Okay, so let's see. Is there anything else I can combine? So let's see. The largest power here is x to the 10. Remember, this is all addition. I'm adding this whole thing with this one. X to the 10 does not combine with anything, so I'm just going to write it down here. So it's going to be x to the 10th power. What's the next power? The next power will be x to the 8th. Okay, let me mark down the ones I am already doing with this color. So I did this one already. Now let's go to the next power, so the lower one. I have an x to the 8, and I cannot combine it, so the plus x to the 8. Plus x to the 8. And I did that one already, so I'm going to mark it down like this. Now let's go to the next power. The next power will be x to the 7, which is this guy over here. I cannot combine this with anything, so I'm going to bring it down over here, so plus x to the 7. So plus x to the 7, and I did that one already, so I'm going to mark that down. So let me mark it here, right? Those the ones that I'm marking are the ones that I'm already done with. Now the next power will be x to the 6. As you can see over there, that power is by itself. I cannot combine it with anything, so I'm going to say plus x to the 6, and that is done already. So go down with this one. Now the next power will be x to the 5th. And x to the 5th is right here. I cannot combine it with anything, so it's going to be plus x to the 5th. And I'm done with that power, or the power x to the 5th. Now the next power will be x to the 4, and I have an x to the 4, an x to the 4 over here, and an x to the 4 over here. And remember, because the addition here is XORed addition, so I have 1 plus 1 is 0. I don't have to put the 0 here. So this is basically the next step in my division of the polynomial. Now, when do you stop? You stop when the remainder is degree 7 or less, because the divisor has degree 8. So what I'm going to do is I'm going to repeat what I just did now with this polynomial and this polynomial here. So what I'm going to say is this. Take the largest power that you see here, which is x to the 10th power, and divide it by x to the 8, right? So I'm going to put that here on the side. So I have x to the 10th divided by x to the 8th power. And if you do apply the rules of exponentiate of the exponents, then it'll give you, of course, x squared, because that's going to be 10 minus 8, that's 2. So I'm going to put that in the quotient part of my division. So I'm going to say plus x squared. And what you do now is do the same as we did before. We're going to take this x squared that is right here, multiply by this whole polynomial that is right there. So it's going to be x squared multiplied by x to the 8. That's x to the 10. So I'm going to have an x to the 10 here. And remember, I'm adding. If you were doing the real division of polynomials, what you do is subtract. But subtraction, remember, in the Galois group is the same as addition. So I'm going to add. So now x squared multiplied by x to the 4, that's x to the 6. I'm going to add an x to the 6. And then x squared multiplied by x to the 3rd is x to the 5th. So I'm going to add x to the 5th. And then I have an x squared that multiplies x. That's an x cubed. So I'm going to add an x cubed right here. And then finally, I'm going to have x squared multiplied by 1, that is just x squared. So it's plus x squared. And I'm going to add them here. All right. So what I need to do is do the addition again, that the same way we did it before. So x to the 10 and x to the 10, because this is XORed addition, this cancels out. Let me mark that down. So let me cancel it out over here. So let me cancel out here. All right. I don't have an x to the 9, but I do have an x to the 8 here, which I cannot combine with anything at all. So I'm just going to write down x to the 8. So I have an x to the 8 there. And I'm going to again mark with this circle things that I've done already. Now the next power will be x to the 7th, which is this guy over here. I cannot combine that with anything over here, so it's going to give me plus x to the 7th. And I'm going to mark it again, showing that I'm done with that computation with this power there. All right. Now let's go to the next power, will be x to the 6. Now I do have an x to the 6 over here, but I also have an x to the 6 over here. I have to add them. So x to the 6 plus x to the 6, and that's going to give me 0 again, because remember, we're adding with sort. So x to the 1 plus 1, that will be 0. So what I'm doing actually there is just canceling out. So this guy here, x to the 6, cancels out with that one. The same thing, if you see, is going to happen with x to the 5th. I have an x to the 5th over here, and I have an x to the 5th over here. Because this is sort addition, 1 plus 1 is 0, so basically x to the 5th and x to the 5th are canceling out. So I'm going to cancel the x to the 5th here with this x to the 5th here. And then finally, what I have just is x cubed plus x squared. It doesn't combine with anything else, so I'm just going to write down plus x cubed plus x squared. Now, do I stop? No, I don't stop, because as this degree is 8, the degree that is right here is an 8, and I don't have degree 7 there. I have to go to degree 7 or less. So I do division again. So what I do is I take the largest power again here, which is x to the 8th, and divided by the largest power that is right here, which is x to the 8th. Of course, x to the 8th divided by x to the 8th is 1. So I'm going to put a plus 1 here in my quotient, and I'm going to multiply now by 1. So I'm going to take this one that is right here, this one, and multiply by this whole thing here. So basically what I'm doing is just multiply this by 1, so that doesn't change anything. So I'm going to add this polynomial again there. So it's going to be plus, I'm going to have an x to the 8 plus x to the 4th plus x cubed plus x plus 1. And I'm going to add. As you can see there, some pretty similar situations are going to happen. The x to the 8 is going to cancel out here. So I'm going to cancel out that x to the 8. Then, can I combine anything else? Well, let's see. So I have an x to the 7 here. So I'm going to have an x to the 7. I cannot combine it with anything. And I'm going to mark that one as already taken care of. So I took care of that one. X to the 6, I don't have an x to the 6. The next power is actually x to the 4th, which is right below that x to the 7, which is this one here. All right, so that x to the 4th does not combine with anything, so I'm going to say plus x to the 4th, and that is taking care of the x to the 4th. Now, as you can see here, I have the next power will be x cubed, which is this. I have it over here, plus x cubed. Again, x cubed plus x cubed is 0 because we are doing sort. So that I don't have to write down x cubed because they cancel out. So they will cancel each other out. So this cancels with this one. Now, do I have an x squared? Yes, I do. I have an x squared right here. It does not combine with anything. It's going to be plus x squared here. And I also have an x here. Doesn't combine with anything. And a 1 doesn't combine with anything. So final here will be this guy here. Now, is this remainder here of degree 7 or less? Yes, it is. That is the answer in the Galois group. So the answer will be this one. It's not the quotient. It's not this guy here. It's not that one. It is the remainder. So the product here, so the answer, let me write down the answer here. So the answer will be x to the 7th plus x to the 4th plus x squared plus x plus 1. This right here, this polynomial, is the answer of multiplying. Let me scroll all the way up. The answer of multiplying this polynomial times this polynomial in the Galois field. So, but basically what we're doing is multiplying this byte by this byte, and we get another byte. So this polynomial, again, this polynomial times this polynomial in the Galois field, let me scroll all the way down over here, will be this polynomial over here. And if you want, you can write down what is the byte. So the answer will be this one, this guy here, and the byte that corresponds to that answer would be just like this. So I start from the last one, so it's gonna be a 0 here, or a 1 in that case. So it's gonna be 1. The coefficient of x is 1, so I have a 1. The coefficient of x squared is 1, so I have a 1. I have no x cubed, so 0. I have an x to the 4, so I have a 1. I don't have an x to the 5th or an x to the 6th, so I have 0, 0. But I do have an x to the 7th, so I have a 1. So this is the byte. This one right here is the byte that corresponds to this polynomial, which is the byte that corresponds to the multiplication. So if you look at this in terms of bytes, let me scroll all the way up again. So what we are saying is this. We say we take this polynomial, or this byte, multiply by this byte. So this byte by this byte, multiply it, and we get, let me scroll all the way down here, we get this byte. Now that is the answer when you do have use the division. Now you can also arrive exactly to the same answer, without doing the polynomial division. So in the next video, what I'm going to do is I'm going to explain how to arrive exactly to this answer without doing the division. Now, which one are you going to do? Whatever is easier for you. It doesn't really matter because the answer is going to be exactly the same. So you do whatever you think is easier for you. Now, so I'm going to stop the video now. So in the next video, I'm going to actually do exactly the same example, but I'm going to approach it in another way. So I'll see you in the next video.